Imputing missing values, k-nearest neighbors, KNN, is a popular imputation technique that leverages the idea that similar observations are likely to have similar values. In KNN imputation, we consider the missing value as a target and find the k-nearest observations in terms of feature similarity. The missing value is then imputed by taking an average or weighted average of the values of these k-nearest neighbors. In the code example provided earlier, we generated a simulated feature matrix using the make_blobs function. We then standardized the features using the standard scaler to ensure that each feature has a mean of 0 and a standard deviation of 1. Next, we introduced a missing value by setting one element to np.nan. We used the canImputer class from scikit-learn to impute the missing value. This class calculates the imputed value by considering the distances between observations and performs an averaging based on the k-nearest neighbors. The key advantage of KNN imputation is that it takes into account the relationships between features and imputes values based on similar observations. However, its drawback is computational complexity, especially for large datasets. Simple imputer. Another common imputation technique is to replace missing values with summary statistics such as mean, median, or mode. This approach is implemented using scikit-learn's simple imputer class. In the example provided, we introduced a missing value, and then we used the simple imputer with the mean strategy to impute missing values. The mean imputation replaces missing values with the mean of the non-missing values in the feature. While simple imputer is computationally more efficient than KNN imputation, it doesn't capture the relationships between observations as effectively. Additionally, using mean imputation may not be appropriate if the data has outliers that could significantly skew the mean. Handling missing data strategies. Deletion of observations. Deleting observations with missing values is the simplest approach, but it should be used with caution. Deleting observations with missing values can lead to biased results and loss of information. This strategy is most appropriate when the proportion of missing values is very small and unlikely to introduce bias. Imputation. Imputation involves filling in missing values with substitute values. This approach retains the observations and avoids loss of information. However, the choice of imputation method depends on the nature of the data and the underlying reasons for the missing values. KNN. Imputation. Effective for small to moderately sized datasets. It captures relationships between observations and imputes based on similarity. Simple. Imputer. Mean, median mode. Efficient for larger datasets. Provides basic imputation using summary statistics. Considerations. When dealing with missing data, it's essential to understand the missing data mechanism. Missing values can be due to randomness, dependencies on other features, or unobserved factors. This understanding helps in selecting the appropriate imputation strategy. It's also important to create a new binary feature indicating whether a value has been imputed. This helps the model differentiate between original and imputed data, preventing the model from overestimating the accuracy of its predictions.